Yes. Hello everyone. So in this video we are discussing a question based on trajectory, how to find out trajectory of any particle. Already in one of the previous question where a relative velocity of approach based question, I will post the link in the description, you can check that. That question we already discussed how to find out trajectory using polar coordinates. That means I was able to find out the trajectory in r and theta terms. In this question, we are trying to find out the trajectory in xy terms, and the most important thing about the question, finding finally the radius of my trajectory. Okay, so radius of trajectory is very important. Radius of curvature of that at one point, we'll discuss that. So before that, let us read the question. The question says, a particle moves in the xy plane with velocity v is equal to k1 I cap plus k2 x j cap, where I cap and j cap are unit vectors along xy axis. K1 and K2 are the constants. Initially, the particle is at the origin. So that is given initially where the particle was at the origin. Find different things. First, equation of the particle's trajectory in y and x terms, and the curvature of the radius of the trajectory as a particle as a function of x. So you want to find out trajectory of the particle as a function of x. So let us first write down the equation of velocity that they are giving. The equation of velocity given is v is equals to k1 I cap plus k2 x j cap. This is the velocity vector equation that they have given. Now from here, we have to find out the trajectory. So this first part, I think all of you would be finding easy only, because the same kind of logic we apply in projectile motion to find the trajectory of projectile. So first, this velocity, can I say the x component of my velocity is k1 and the y component of my velocity is k2x, correct? So here I can write dx by dt. The x component of my velocity is basically rate of change of x is equals to k1, and the y component of velocity is rate of change of y, that is given as k2x. So if I'm interested in finding x from here, I can integrate this in this way, and for finding y, I can do it as k2x dt. While integrating, the limits of my integration would be, because my body started from origin, the x value starts from 0, it goes up to some random x, and time obviously starts from 0 to some time t when the particle is at x. Okay, so this would give me x is equals to k1t. Same way, if I want to integrate this here, the limit of my integration goes from the dy. The y term would go from 0 to y, and the time would go from 0 to t. But the problem is I cannot integrate x with respect to time. So I'll have to change this x. For that I can substitute from this equation. So now my equation became dy's integration is equals to k2 times x can be written as k1t. So now I'll be having k2 k1 integration t dt, right? Limits would be now 0 to y, starting from origin to some position y, and at time t equal to 0 I started my motion, and at time t equals to t it has reached y. So just integrate it, you will be getting y is equals to k1 k2, integration would give you t square by 2, right? Now this is equation of y. I have got the trajectory, actually I got the trajectory equation as y is equal to, but the problem is this can't be called as trajectory because this is not relationship of y with respect to x. I want relationship of y with respect to x. For that I can again use the same equation, resubstitute for the time. So now if I substitute that, I'll be getting y is equals to k1 k2. Instead of t I can substitute it as x by k1. So I'll be getting x square by 2 k1 square. So this would finally give me y is equals to, what do I get? If I k1 k1 cancel, I'll be getting k2 by 2 k1 times x square. It's basically a parabolic equation. So this is the trajectory of my particle, and this was the question of the first part. Now what about the second part? In second part, they are interested in finding yes, curvature radius of the trajectory of particle as a function of x. So now I'm interested in finding the curvature of that, right? If I want to find radius of curvature, there are basically two methods. One is by using velocity at some random location. I can use the velocity and I can find the acceleration at that location. If I know acceleration, then what I can do is take the velocity at that position and also get the component of acceleration which is perpendicular to velocity. Using these two and centripetal acceleration concept, we will be able to find out radius. In projectile motion, most of the cases we do that, right? But in this question, because acceleration is not given, I will have to find it out by differentiation and all. We can directly go with the mathematical way of finding the radius of curvature, and that formula for finding the radius of curvature is r is equal to 1 plus dy by dx whole square, okay, divided by d square y by dx square. Actually, we should not call it as d square y by dx square. We should call it as d2y by dx2. That means it is double differentiation like that. And this power 3 by 2. Okay, this is the equation that we should use, the mathematical relationship to find radius of curvature whenever we want. I will show you the derivation of this in a moment, right? Let us first of all find out the value of radius for this question, and after that I'll show you the derivation for the same. So for finding radius of curvature, we'll be requiring what all things? I require dy by dx. So let us first find out that dy by dx would be equal to, what do I get if I differentiate this with respect to x? 2x will be coming and 2 gets cancelled. So I'll be getting it as k2 by k1. Okay, this would be my differentiation with respect to x, dy by dx. Okay, and there is an x also, right? X also pending. Now, if I double differentiate this, that is d2y by dx2, that would give me in double differentiation, differentiating this once again would give me k2 by k1. So these are the two quantities or values that I require. Once I have that, now I can find out the radius of curvature as r is equal to 1 plus dy by dx is this value, square of that would be k2 square divided by k1 square x square, the whole power 3 by 2 divided by the double differentiation would be k2 by k1, k2 by k1. Okay, that's it. Now if I want to, I can solve this. I can take out the k1 square outside, it will become cube, right? And then this k1 can go up, it will become k power, that cancellation would happen, it will become k square. We can do that, but I would prefer to stop it here because solution all of you will be able to do. My interesting thing, that is an important thing for me, was to show you this formula, and the next part is the very important one. We are going to derive the same